Hello, students. Mr. Murphy here. Lesson 8, estimating quantities. So we are going to compare and estimate quantities in the form of a single digit times the power of 10. So it's kind of scientific notation. We will use our knowledge of ratios, fractions, and exponents to simplify our expressions. All right, so we're doing specific comparing and estimating with powers of 10. Okay. Remember, a ratio is basically a division problem. So let's try a practice problem. The population in New York was 7,248 people. Now, and then 150 years later, it was 942,292 people. How many times greater was the population between 1870 and 1723? So I'm going to put these in powers of 10. So 7,000 is a little bit less than 10,000. So it's about 10 to the fourth. 4 zeros, so it's 10 to the fourth. 942,292 is a little bit less than a million, and there's 6 zeros, so that's 10 to the sixth. So we're going to compare by dividing, put them in a ratio, 10 to the sixth divided by 10 to the fourth. Just subtract the exponents. 6 minus 4 is 2. So that's about 10 squared. So in 1870, the population of New York was about 100 times larger than in 1723. Now, if I put these actual numbers in a calculator, I get 130. So this is an approximation, this is an estimation that we did in our head without use of a calculator, and it only took us a couple of seconds. So it's a great approximation for the amount of time it took to figure it out. So you try one on your own. You are going to approximate if the average house has $7,000 in credit card debt and the U.S. Treasury has 16,755,133,009,522 in debt, how much greater is the U.S. debt compared to this debt? So put them in powers of 10 first, and then divide. I'll give you a second. All right, pause the tape. So 7,000 is about 10,000. So we do 10 to the fourth. 16 trillion, it's closer to 10 trillion than it is to 100 trillion. So we're just going to count the number of digits here. If I count them, that's why we have these commas here. 3, 6, 9, 12, 13, 14. So there's 14 digits, so that's 10 to the 14. We're just going to divide. Pause real quick and divide if you haven't done that yet. 10 to the 14th divided by 10 to the 4th. 14 minus 10 is 10, so that's 10 to the 10th power. So our national debt is greater than the average household debt by 10 to the 10th power, or about $10 billion per household. So try another one on your own. If there's 3 million students in all K through 12 schools in New York, and there's about 8 times 10 to the second power number of students in one middle school, how much bigger is the total number of students compared to the one middle school? So put them in powers of 10. All right, so 3 million is about 3 times 10 to the 6th, right? There's 6 zeros, 3 times 10 to the 6th. 8 times 10 squared is 8 times 10 squared. So we're going to divide these. The 3 times 10 to the 6 is larger because the 6 is larger. This is only like 800. So if I want to divide these, now I've got a number times the power of 10. So I use the commutative power to separate these. So I have my 3/8 times 10 to the 4th. 3/8 as a fraction becomes a decimal. 3 divided by 8 is 0.375 times 10 to the 4th. Well, I've got 3 decimal places to use here, so I might as well use up all of them. Move 4 spots to the right. 3, add a 0 for that last missing spot. 3,750. So the total number of students in the K through 12 schools in New York is about 3,750 times the number in just one middle school. Try this one. If you have 30,000 breaths per day and you live 80 years, or about 30,000 days, how many breaths will you take? What are you going to do to solve that? Think for a second. Am I going to add, subtract, multiply, or divide? So if it's 30,000 per day times the number of years, that's going to be multiplied. So 30,000 is 3 times 10 to the fourth, and both of these are 30,000. So I'm going to multiply 3 times 10 to the fourth times 3 times 10 to the fourth. Through the magic of commutative property, I'm going to move these around because I'm not adding, I'm multiplying. So I can move and multiply in any order I want. So I'm going to do 3 times 3 is 9, 10 to the fourth times 10 to the fourth. I'm going to add the exponents. That gives me 10 to the eighth. My x is a little off here, but it's 9 times 10 to the eighth. So I'm going to put 8 zeros in there. So it's about 900 million breaths per day or per life if you live 80 years. So in summary, you can get close approximations, and the closer you are with your approximation, the closer you will be to the correct answer. So if I just do a power of 10, I was off by 30 on that first problem. But if I do like 3 times a power of 10, I can get much closer with my answers. And we can multiply and divide those numbers pretty easily. So, all right, that's 7 minutes. That's more than long enough. Good luck.